Question 9 is about geometric sequences. We've been given the first three terms in terms of k, and we're asked to show that k satisfies this equation. So let's have a go at part A. So I've written out the three terms that they've given us, and above it I've written what the terms represent. This is A, AR, and AR squared. Now, if I divide the second term by the first term, AR divided by A, I will get R. Equally, if I divide the second term by the first term, AR squared divided by AR, I will also get R. So I can set up an equation, because they are both giving R, in terms of K. If I cross multiply, I get this. This is clearly going to turn into a quadratic in K, which is what we're after. Pushing everything onto the left-hand side, I get this. Now taking a factor of 2 out, I get this, which is what the question wants. So we've done it. So in part B, we've been told that the sequence converges. In other words, there will be a sum to infinity, and there will be a value of k which satisfies the fact that these numbers will be going downwards. So let's first of all solve this quadratic and find the values of k that make this equation come true, and see if we can show that one or other of them causes this sequence to converge. If I put that into a calculator, I get that k is equal to 20, or k is equal to 3/4. Now, the other proof that we are going to employ here is if this sequence converges, AR squared, R must be less than 1. Let's find out what R is if I make k 20. So this is my value for R, the first term divided by the second. 12 minus 3 times 20 is negative 60. 12 minus negative 60, this is negative 48, and on the bottom 64. And this, if you cancel it down, is negative 3/4, which is indeed less than 1. So this is a possible answer. So substituting k's 3/4, I get another value of R, and this turns out to be 5/3, which is not less than 1. So this doesn't satisfy the requirement that the sequence converges. So therefore I can say that R is equal to negative 3/4. So all we now need to do is the sum to infinity. So substituting our values in, this is equal to 64 divided by 1, R being negative 3/4. This is 1 plus 3/4. And this turns out to be 256 divided by 7. And that's the answer to the second part of question 9.